So this is lesson 1.2. So we're going to solve something that is not an equality. Sorry, that is nonlinear. So anything that has exponents of greater than or equal to 2 in the equation. So here's our first example. So we have x squared is greater than or equal to negative 2x plus 15. So in order to do this problem, what you need to do is you need to move all of your information for your nonlinear function to one side. So in this case, we've got x squared plus 2x minus 15 is greater than or equal to 0. Now what I'd like you to do is I'd like you to split, i.e. factor, our equation that's on the left side because it looks like a quadratic. You know that the following is true. X plus 5, x minus 3 ends up being the factor of that equation. Now, the last thing that we want to do for this thing is we want to do an aside to determine what the zeros are for this function. So for the zeros, we go, well, x plus 5, x minus 3 equals 0, which means our zeros are x is equal to negative 5 and positive 3. Okay, based on this, we're going to use a thing called the Sine chart method. Using the Sine chart method, this gives us something very unique. It allows us to go and create solutions in interval notation based on a chart of information that we use. Now, let us go take a look at these things. You'll notice that when we did our aside here, we found the zeros of this equation. The reason why we found the zeros of this equation is because when we were looking at our original equality, it said that the quadratic was greater than or equal to 0. Okay? Now, the reason why I'm teaching you this is that sometimes you're not able to actually just graph the parabola and find out what values, what points work for this thing. So we sometimes have to do this method, okay? Now, here's what you're going to do. I need you to find all the points in our parabola or where our function is equal to 0. So we do that first of all. So we lay those out. We lay those out as the x value of our chart. So the x values of our chart has a negative 5 and a positive 3. So I'm actually just going to put that in here, negative 5, and put a space and put positive 3 somewhere a little bit to the right. Then what I do is I fill all the space with interval notation. I know, so think of this as a number line going from here, from negative infinity to just before 5. So that's what our round bracket means. Then we have negative 5, to negative 5. And then we have negative 5. And then what we're going to do is we're going to go for all points between negative 5 and positive 3. So that is our next interval. And then we have to look at all the intervals from 3 to positive infinity. Now, you remember that we spent some time and factored our function, and we have these two factored values, right? X plus 5 and x minus 3. What we're going to do now is we're going to basically create a table of values that represent whether these things are positive or negative or 0 in each one of these intervals that we have defined. So now, in this first chart here, I'm going to have x plus 5. All right? So for all points less than 5, which represents this spot here, this spot here, okay? When I go and punch in a number, say -6, which is in that interval, this value is negative, because when I plug it into my equation, -6 plus 5 gives me a negative. Now, at x is -5, we end up with 0. Between -5 and +3, pick a number. Let's say the number 0. Is 0 plus 5 greater than 0? Yes, it is. So that's a positive. So all we care about is whether it's positive or negative. Now, 3 plus 3, positive and positive. Now, here's the trick. You want to make your life easy? Identify where your zeros are for each of your lines. So I know where my 0 is, right? I test the first point. For this linear term in my factorization, if it is negative before my 0, then after my 0, I have to be positive. So it kind of looks like this, right? On the number line. That's it. That's all we're testing, right? And what this does is it saves us a massive amount of work, right? So now we just write x minus 3 right here in our next line, x minus 3. And now that we have x minus 3, let's go to our 0 for x minus 3. If I put in 3 into x minus 3, this is 0, right? So now what I'm going to do is I'm going to test all my points, which are before 3. Before 3, my graph is negative, because if I punch in 0 minus 3, it's negative. This is negative, and this is also negative, which means that after 3, my graph is positive from 3 all the way to infinity. Now, when we combine both of those factors, we get x plus 5 times x plus 3. And we imagine that we're multiplying. What's a negative and a negative give me? A positive, doesn't it? What does a 0, what's 0 times a negative give me? 0. Positive and negative, negative. Positive and negative, positive and 0, 0. And positive. Now, when we were looking at our original calculation, when we moved everything to the left side, we were looking to see what values for x plus 5 and x plus 3 being greater than 0. And all I have to do is I have to identify the sections of this for which I have stuff greater than or equal to 0. All right. And now those happen for these intervals. The intervals are from negative infinity to, well, let me check off the stuff that works. So I'm going to check off that works, and that works, right? Now, because this -5 is on one of the boundaries, we're going to have to write -5, and instead of a round bracket, we're going to use a square bracket. And then we're going to use the U sign to represent the union or combining with the other stuff that works for our greater than or equal to equation that we have for our nonlinear equality. So now this one here states that we're going to go from 3 all the way to infinity. And we literally just had to read the top portion of our chart to get most of what we were looking for in our solution. And we're good. And we can say the solution is boom. Pause the video and go back over this and see if you can figure out what we just did. Remember, the objective function, what I call the objective function, that's this thing right here, this thing that I highlighted in blue, is what we were looking to solve. We were given the original equation, which was equation number 1 here, right? And when we got that equation, what we did was we translated it into 2 linear multiplications and then came up with a solution. All right, we're done. For this next one, we have x minus 4 squared, x plus 8 cubed is greater than 0. So now we need to solve it, okay? It's already in factored form, so we know that its zeros are x equals negative 8 and 4. So what we can do is we can go and set up our basic table again. So we'll start by, in red, creating the x values that we're going to use for our table. And we're going to write down our zeros, which we have negative 8 and 4. And then before 8, we have the interval from negative 8 down to negative infinity. And then between negative 8 and 4 is negative 8 to 4. And then above 4 is going to be 4 to infinity. Now, let's go and take the parts of this group. So I've got this one here and this one. And instead of being linear like last time, what we're going to do is we're going to use x minus 4 squared. You know that at x minus 4 squared, at x equals 4, our graph is 0. All right? For x being greater than 4. So let's say if x was 5. 5 minus 4. So this problem here turns into 5 minus 4, which is 1, and then square it. You get a positive. Okay? So now that's good. So that means this portion here is positive. So now if we have x minus 4 squared, again, this is also positive, this is positive. So this portion between 8, negative 8, and 4, we just pick a number between 8, negative 8, and 4, punch it into our parabola, our x minus 4 squared, and we get positive, and we end up with positive for this last bit of my chart. So now for x plus 8 cubed, you know that x plus 8 cubed is 0 at negative 8. Now, we have to figure out what happens to our cubic function. So our cubic function is going to be negative in the interval between negative infinity and negative 8. And that's because when you punch in negative 8, negative, say, 9, plus 8, you get negative 1. You cube it, it ends up being negative 1 cubed, which is negative. We check our points above. So let's imagine we have a point of, say, negative 7, which is in this interval here. So -7 plus 8 is 1 for this form. And when we punch that value in, we end up having 1 cubed, which is positive. And to do the same again for the next point, and then it's still positive again for the next value here. So now when we combine all our functions together, when we multiply them, so we x minus 4 squared times x plus 8 cubed, when you take the resulting signs, positive times a negative is negative. Positive times 0 is 0. Positive times positive is positive. 0 and positive. So we're looking for our original function to be positive. We're looking for our original function to be positive, actually greater than 0. So all we need are the intervals for which we have positive values, and we have positive values here and here. So since we have that, we can say the solution is and then we union it. We bring them together with a union of 4 to infinity, and we're done. Pause and take a moment. See what you get. And now we'll move on. So now what we're going to do is we're going to take x is less than 3 minus x 6 over x plus 2. So we'll move everything over to the left side. So we have less than or equal to 0, which is x minus 3 plus 6 over x plus 2. Now we're going to have a common denominator of x plus 2 for both of these fractions. So we got x minus 3 over 1 plus x plus 2. So we're going to multiply the top and bottom of the x minus 3 over 1 to be x plus 2. So we're going to have x minus 3 over 1 times x plus 2 over x plus 2 plus 6 over x plus 2. So now what we've done is we've created a situation where we have the following. When we take the x plus 2 and multiply into the top half of that equation, you're going to get x squared minus x minus 6, and then we have plus 6, and that's just the numerator because all we did was expand into this equation, and then we've got plus 6, and then we're divided by x plus 2, which is less than or equal to 0. So now when we simplify, we're left with x squared minus x over x plus 2, which is less than or equal to 0, which is less than or equal to 0. And factor the top, you have x times x minus 1 divided by x plus 2. So now that we have that, remember x cannot equal -2. So, and on the top, we factored it out to be x and x minus 1. So our zeros, the zeros for this problem are x is equal to 1 and 0, and it's undefined at x is equal to -2, based on what we started with right here. So now let's set up all of the possible x values that we have for our inequality. So our x values are x, and we have points that are defined at 0 and 1, and we have an undefined value at -2, so we have to have that. So now we need to show what our values are going from -infinity up to -2, then from -2 to 0, then from 0 to 1, and from 1 going all the way up to positive infinity. You'll notice that we had to show all of these different things here, okay? So now we look at our final calculation for this original inequality. We have 3 parts to consider. We have to consider the graph of x, and we have to see where it is 0 in our list of intervals. So between -infinity and -2, just pick a number like -3. -3, it's negative. -2, it's negative. X is negative. Between -2 and 1, let's choose the value of -1. This is still negative. This is 0. So 0 is 0. And then it becomes positive afterwards. Now let's do the same for x minus 1. For the value of x minus 1, we know that our original graph is 0 here, where x is 1. And we know that to the right of 1, if we punch in a value of, say, 2, any number between 1 and infinity, let's say we punch in 2, this value is positive, then before it, it's going to be negative. Now, we know that for this portion of our graph, at x plus 2, we know that our graph is at -2, it is undefined. But before -2, let's say -3, this overall x plus 2 is negative. Then after it, it's going to be positive. Now we can go and combine all 3 to come up with our equation. So we have x times x minus 1 divided by x plus 2. And we have the following for our multiplication. 3 negatives give us a negative. 2 negatives and an undefined is still undefined. 2 negatives and a positive multiplied together is positive. This is 0. So now we have 2 positives and a negative, which gives us a negative. 2 positives and a 0 give us a 0, and 3 positives give us positive. So when we look at our original equation, we're looking for values for which this whole fraction is less than 0. And that only happens here and here. And when we look up, less than or equal to 0. And it only happens here, here, and here, and here. Which means Our solution is for the first negative sign, we have the points negative infinity to 2 to negative 2, but not including 2, unioned with, well, we do have a 0 here, so we're going to have a 0, and we're going up to 1, but we need to include 1 and include 0, so we must have a square bracket for both of those intervals. And we're done. So just quickly take a stock of what you see, and then we'll move on to the next lesson. So for this basic equation, you'll notice you have 4x plus 5 over x squared, which is greater than or equal to x plus 5. One of the things that you need to basically tell me right away is what my undefined values are. In this case, x cannot equal 0, and x cannot equal negative 5. And that's due to the denominators of each of these problems here. So you'll see for x squared, if I set it 0, our denominator goes to 0. If I set x is negative 5, that denominator goes to 0. Okay, so now what we'll do is we will move everything over to the left side of our equation. And we have greater than or equal to 0, and we have 4x plus 5 over x squared, and then we have minus 4 over x plus 5. So now we need a common denominator between each of these. So for the first one here, this one, we're going to multiply the top and bottom by x plus 5. And then for this one here, we're going to multiply the top and bottom by x squared in order to have a common denominator. And in doing so, you're going to have the following resultant calculation. You're going to have 4x plus 5 on the top, and then you're going to multiply that by x plus 5. And then for the second half of the numerator, you're going to have negative 4 times x squared. And it's all over x squared times x plus 5, which is greater than or equal to 0. Now that is just a quick and dirty way of doing multiplying out the numerators. You can do the extra steps if you're not quite sure of how to combine the numerators, where you actually show multiplying the top and bottoms. Now that I've done that, what we're going to do is we're going to expand these two and simplify the numerator. So we're now left with 4x squared plus 20 plus 25x plus 25 minus 4x squared all over x squared times x plus 5. You'll notice that on the denominator, I'm not going to go and expand that, because all that's going to do is going to make my calculations more difficult. So now that I've done that, we simplify the top, and we're left with 25x plus 25 divided by x squared times x plus 5 is greater than or equal to 0. And our final factorization of the top is x times x plus 1 over x squared times x plus 5 is greater than or equal to 0. Now, if you want, we can drop the 25, because if we divide both sides by 25, we can get rid of that 25 on top. but I'm sure you won't want to do that. So here's what we have for our intervals. Remember, we said that in our original equations that x could not equal 0 and x could not equal -5 based on the original inequality. So now what we'll do, we'll use all of those key values and our zeros from our top of a fraction here to find the intervals that are important. So in this case, based on our final equation for our inequality here, we have values of 0 and -5 being important, i.e. where our undefined values are. But then for the numerator of our equation here, we have 25x plus 1. So I'm just going to focus on the x plus 1. When I go and punch an x plus 1, that only becomes 0 when x is equal to -1. So that is an important value in our intervals. So now let's fill out everything in between. So we have -infinity up to -5. Then we have -5 to -1. We also have -1 to 0 and 0 to positive infinity. So now, when we fill this out, the only thing we really care about is our x plus 1 factor, right? Our x plus 1 factor is 0 at position -1. But then it is positive to the right, but then negative to the left. And you can check that by punching -1 in for x plus 1, negative, say, for say the point, any points between -5 and -1, which is here. And all you do is you just punch that in, say, -2. See what value you get. -2 plus 1 is -1. It's negative. Check -5, negative. You can do the same for the last bit. And now let's go and take a look at x plus 5. So for x plus 5, you'll know that at 0, it is 0. At -5, x plus 5 is 0, and it's positive to the right, but negative to the left of -5 for each one of those intervals and points. So now we'll go and punch in x squared. For x squared is 0 here. But then it's positive here, positive here, positive here, positive, positive, and positive. Now, really, what we should say is, for our combined function here, this part here, for x plus 5, it's actually undefined. For x equals x squared, this is also undefined. So now when we combine all of these things into our final calculation, we have 25 x plus 1 over x squared times x plus 5. So now we need to check for all points where we have greater than or equal to 0. So we're just going to combine these three columns here and see what the multiplication is. And in this case, we have a positive. Here we'll have an undefined value. A negative and two positives is negative. We have a 0 here. We have 0 0 times 0, yep. And we have a positive value for this column and an undefined for this column and positive again for this column. So based on that, our solutions have to be greater than 0 and positive. So they only occur here, here, and here. So therefore, the solution is -5, -8, negative infinity to -5, based on that first column. The next column here, we have the point -1 and this point here. So we have a combination. So when we have this column here, where we have our -1, we also have this. So that means the combination of these two make our union become the union of a square bracket, because we have to include the 1, -1, and 0, an end bracket. And then finally, we have a union of 0 to infinity. And we're done. Your homework is page 10, number 43 to 57. And that's the odd ones are the ones that have solutions. You should be able to do all of the questions though. Good luck.